Okay, great. So now we are recording. Okay, wonderful. So our presenter today is Dr. Frank Galgano, or Professor Frank Galgano, who came here after serving 27 years in the U.S. Army, retiring as a lieutenant colonel. And you're the founding director for the Geography and the Environment Department. Is that correct, Frank?
That's true. Yes.
Yeah, wonderful. So, great work that department has done in your tenure and now beyond. Frank is still teaching, very much still teaching within that department. So has a lot of wisdom and stories to share with us of what he's been able to accomplish. So we thank you, Frank, for providing this presentation, and we look forward to all you have to share with us.
Let me go ahead and get going here, and I want to get rid of all of those little screen things. So Liesl approached me and asked me to do this, and I was happy to do so. So the idea was to talk about ways of trying to integrate sustainability related topics into courses that you would say are not necessarily on the surface sustainability related. And I teach a couple of those, and I'll show you some examples. I'm not going to tell you how to do it, obviously. I thought showing you some examples and giving you some feedback on what I've discovered maybe could assist you in trying to do that as well. So, sustainability is an interesting topic. One of the things I would add is with Andrea Welker and Paul, we started the sustainability minor back in 2010. And Paul Rozier and I put together the Introduction to Sustainability Studies course. So I've been dealing with this topic in the classroom now for about 11 years, 12 years. So the thing about teaching sustainability, many of you have seen this model or one that's similar, and I'm not going to spend a lot of time on it. The key here is this sort of central part of the model. And what that means is sustainability occurs at the nexus of just about every discipline and subject that we teach at the university. The sciences, the engineering, humanities, social sciences, the arts, and I don't want to leave any out, but so it is possible to do that. And I tend to think of it, I put the more simplified people, planet, profits sort of idea, and that's how I try to think about it as I look at my courses. So sort of 4 pieces of advice that I would give you that I've discovered is, when you're teaching a course that's not necessarily sustainability in quotation marks, the thing is, it's easy to do, but I would say make them interesting and memorable. And I'm hoping that I'm doing that with my students. But I found out that the many are the enemy of the few and the good. And what do I mean by that? I think you should, in a course that, and I'll show you an example of one of mine, that is not necessarily a sustainability course, I would focus on adding 2 or 3 examples into the course rather than trying to do a lot. And it kind of goes to the next 2 bullets. Don't force the issue. Make your examples clear and consequential, and have a direct connection between your subject and sustainability. So my little cartoon there, the student isn't wondering, why are we doing this? So you want to make it intuitively obvious to them. So I'm going to give you 3 examples and 3 different courses and 3 different ways of doing it. The first will be a simple add-in to a lecture, a short case study in which we generate some discussion in the class. The example relates directly to the subject, and the example is an issue of water and municipal water supply, infectious disease, and sustainability. The second is in a natural science course. I'll talk about sea level rise. And then the third is in a social science course. I'm now teaching our Geography of the Middle East course, and I'll give you an example of population. And I'll give you some other examples as well. So my background as a geographer is in the natural sciences side of geography. I worked at the Coastal Lab for Coastal Research at the University of Maryland. And my dissertation topic was looking at these inlets, and here's Ocean City from the time it was pierced in 1933, stabilized. And the idea is there's a sort of evolution of the downdrift landform. So it was a look at wave energy, sediment supply, hydraulics, and why these places are wildly eroding after they get breached. And they all have the same sort of pattern. So that's my background. Let me admit this person. And the courses that I teach mostly are these right here. I teach 1750 every fall. That's a lab course. It's required of all of our majors. I mentioned that Paul Rozier and I wrote Introduction to Sustainability Studies. I do the Middle East now, land use planning, I teach every other year. Geomorphology, I teach every other year. I team teach medical geography with Bob Leggiardro. And occasionally I teach the Geography of National Security course. And I've done a couple of graduate seminars and other things, but these are the ones that I principally do. So the ones with the check marks are the ones that I would say are sustainability courses. Obviously, Introduction to Sustainability Studies, it's difficult to teach that because it's what do we cut out? It's very easy. It's overflowing with material. Land use planning is a good course to teach from a sustainability perspective because sustainability is the integrating thread throughout the entire course as we look at sustainable land use, sustainable use of watersheds, et cetera, et cetera. Medical geography, I wrote that and team taught it with Bob Leggiardro. He's the primary instructor now. I teach about a third of the lectures for that class. I do the geography, he does the epidemiology, but that course, the sustainability stuff is very, very easy to integrate. I'll give you examples from these other three. Geotechniques is a technology-based course. It looks at methods and technologies, and it's not intuitively obvious that sustainability could be worked into that class. Middle East is a little bit easier. Issues of population, water, and energy are obviously in the lesson. And geomorphology is a natural science course where sustainability, again, not intuitively obvious as a course where sustainability might come out in the lesson. So I'll give three examples. And this first one is from the 1750 class, Geotechniques. And this is where we look at geographic information systems and infectious disease. So very briefly, this is how the Geotechniques course is organized. It's 6 units. We start out with mapping and cartography. We perform surveys. We do project planning, and hopefully this fall, our drone will be used in a lab. This fall, we have computer cartography, digital elevation models, geographic information systems, GPS, and remote sensing. And the example I'm going to give you is from Unit 4. This is also a lab course where everything they do in the classroom is then practiced in the lab. So in Lesson 13, in the first of 2 lectures, the Introduction to Geographic Information Systems, I give them a case study from the 1854 London cholera epidemic. And the outcomes I'm looking for is the power of GIS as an analytical tool to reinforce that. It's a really great example of basic problem solving, but also in terms of sustainability, it's the sustainable municipal water supply and a look at infectious disease, population, and mapping. So it's as I mentioned, it's a historical case study. It comes up in the lecture, and I'll show you some of the discussion questions that I try to use to lead the discussion here. So some of you may be familiar with this example, and I don't have really time to get into very deeply, but in 1854, there's a cholera epidemic, and it's centered in Soho in London. And in a very small area, in a very short period of time, 616 people die of cholera. And the hero of our story, Dr. John Snow, is a physician. And at the time, the miasma theory is basically how we looked at disease, right? How do you get sick? How do we get cholera? How do we get any diseases? From bad air or noxious odors. And in 1849, he writes, for what was back then a seminal paper on the mode of communication of cholera. He still didn't understand germs, as we didn't as a population, but his idea was that it's not because the air smells bad that people are getting sick. And he had sort of intuitively, he thought it was water. So he was presenting theories for alternative transmission. And lo and behold, this cholera epidemic breaks out in London, and he looks at, he asked where it's happening, and he did it by examining relationships across geographic space. And this is important because the entire public health movement that happens in Western Europe and the United States comes out of this cholera epidemic. Shortly thereafter, Chicago put in its sewers, the New York City tenement laws were being passed. We began to realize, as a matter of our urban planning, that we had to account for public health and sustainable water supplies and resources. So a geographic information system, as the students learn in this lesson, really relies on two basic things. We have location data. These are points with XY coordinates, and attributes. These are magnitudes and explanations of things. So John Snow is using basically three attributes. He has streets and alleys, which you don't see the alleys on here, which provide some more connectivity, as you'll see in a moment. So he had the streets. He had the location of where people had died from the disease, another attribute that now we can spatially locate. And then the third attribute he had was the location of these pumps that were pumping groundwater. So the idea is the people would go to the pump in the street, and they would pump their daily water and bring the bucket back home. And his idea was, he believed strongly that this was a water-based disease. And he took these three attributes together and he assembles a map. So we have our roads, we have our fatalities, and we have our pumps. And Snow quickly realizes that the people are all concentrated around this particular pump here on Broad Street. And he recommends shutting down the pump. The pump is shut down, and the incidence of disease goes away rather dramatically. And in fact, here is the actual map from his publication. The only thing we did different was we added these highlighted pump locations because it's hard to see them in the original. And the amazing thing is if you look at the scale, most of these people were dying in the area about the size of a football field. So this is a really dramatic disease and problem. So we talk about this issue, but what I do with them is a little bit, I think, fun, and they seem to enjoy it, is they're only being introduced to GIS now, and they'll have one lab the next afternoon. But what if John Snow would have had access to a modern GIS? How could he perform his analysis? And we use a couple examples. I'm only going to show you two. One is using Thiessen's polygons, which is essentially a way of calculating the areal mean of a set of occurrences. And essentially, when we set up a polygon like this in the computer space, the computer analyzes and it says, every point in this polygon is closer to this nodal point than it is any other. And so quickly, again, this sort of more rigorously identifies the Broad Street pump as the main problem here. The other one we show them is hotspot analysis, which is basically identifying clustering of observations and data points. And it looks at statistically significant clustering based on distance to our nodal point. And again, you can kind of see the sort of, these occurrences are attributed to the Broad Street. Well, so there's a couple others that I show, but I don't want to belabor the point. And it kind of shows them the power of GIS, and then lead about a 10-minute discussion afterwards. What does this case study tell us about sustainable water supply? What does this tell us about sustainable development? What does it tell us about the power of geospatial tools? And it is kind of a fun discussion to have with them. And it's pretty simple. It's pretty straightforward. It reinforces the key points of the lesson, and it enables me to bring out an issue of sustainability. And it is one of the, it's widely considered to be the first GIS. So we do that. And I'm hopeful that for this fall, and based on our new schedule, I'll probably teach this lesson, it looks like the last day of September. would like to expand it a little bit and use the New Rochelle example from New York using the COVID-19 pandemic, which was one of the big hotspots in the state of New York. The data are available, and sort of do a side-by-side and kind of do an example of then and now. So that's an example of a short case study that's worked into the lesson. Other examples I use, I have a set of historical photos of Villanova. This one's 1842, and you can kind of see Villanova in this area right here. I have a 1952, a 1966, this one's 1971, and I have a couple of others here. And essentially we look at Villanova, very small, very rural Radnor, all the way up to the Radnor and Villanova we know today. And I asked them some questions about sustainable development and land use they can get from that. So that's another example that I use in class. The second one is in geomorphology, and the example here is sea level rise. So very quickly, for those of you who are not familiar, geomorphology is the study of landforms, scientific study of landforms, and the processes, mainly physical and chemical, that create them. And a standard geomorphology course looks like this. We look at endogenic forces, those that are occurring within the earth that build the land upward, and then these exogenic forces that shape the landscape as we see it. And we end up looking at glacial, fluvial, dunes, aeolian, and deserts, and of course, coastal landforms. And the example here is in coastal landforms. So this, again, is not a class that would seem to lend itself necessarily to sustainability. So I use this map in the class, and I made it. I think it's very compelling because if we take away all the countries that don't have a coastline, that's what's left of the world, and sort of some Kevin Costner Waterworld deconstruction of where we live. But there's a lot of different estimates about how many people live within the coastal zone, 60%, 80%. It's a substantial amount of the world's population live in the coastal zone, which means that they are affected by tides, which means they are affected by sea level rise. So this makes it a very important and compelling example. So this is lesson 22. Coastal processes and landforms, and it supports the discussion of eustatic and relative sea level rise and their effects. And the outcomes I'm reinforcing is the geographic variability of relative sea level rise, the effects of various IPCC projections of sea level rise, and its impact on sustainable development. So not to belabor the point, sea level rise, as you know, is a variation in the level of the ocean surface. And we use, the standard is the mean sea level. It's an average over many, many decades, the midpoint between high tide and low tide, we call it mean sea level, and that's what we use. The thing to remember is there are many factors, of which temperature is only one, that affects sea level rise, and very important to understand geologic timescales. So what do I mean by that? So if we were to go back 120,000 years, we would be in an interglacial like the one we're in now. Now we're in the Holocene interglacial. It's warming, and the warming is being accelerated. Back then, at the peak of the Sangamon interglacial, it was warmer than even today, if we believe our fossil and geologic evidence. And if you were to come to the East Coast, Washington, D.C., Baltimore, Philadelphia would all be coastal cities, and New York would be underwater. And we have barrier island formations that we can find underneath these cities. There's geologic evidence that supports all of this. And in fact, this is what the United States would have looked like 120,000 years ago. If we go back about 18 to 15,000 years ago during the peak of the Wisconsin glaciation, the East Coast is about 150 miles to the east at the edge of the continental shelf. So what this means is the coastal zone is very dynamic in short and long timescales. And over geologic time, many thousands of years, sea level has gone up and down, and the shoreline has traversed many hundreds of miles. There's also two components of sea level rise that we want to get our students to understand. There's eustatic and relative. Eustatic is the global average. If we take away all of the regional differences that affect sea level rise, the eustatic rate of sea level rise is now about 1.8 to 2 millimeters per year, and that is increasing as things get warmer. Eustatically, sea level rise is a function of global meltwater and the steric expansion based on temperature of the upper surface of the ocean. In a relative sense, site specifically, sea level rise is very variable, and here are 6 of the major things that affect that. Glacio-isostatic adjustment is basically the rising and falling of the land because of the last glaciation, all the way to humans extracting water and oil and so on. So what this means is geographically, over short distances, sea level rise is very variable. So here's an example. This is the East Coast, obviously. If we look at Boston, about 2.6 millimeters per year. New York, 2.75. Philadelphia is at 3. Atlantic City is at 4. Lewis is at 3.58. We work our way down to Baltimore. So if we start down here at Key West, all the way in the southernmost station, these are from tide gauge records. It has among the lowest sea level rise, and we work our way up across the East Coast. It gets higher and higher until we get to Atlantic City, which has got the highest. And we work our way up to Quebec and up into Canada, which has actually negative sea level rise because the land is still rising because of being unloaded from the glaciers. The key about all of this is the glaciers push down the land up here in the north, and it isostatically force the land to rise down here. And Atlantic City is at the exact peak of that glacial forebelow. So the land is sinking rapidly and the ocean is rising. So Atlantic City has the highest sea level rise on the East Coast. And this is part of what we work on in the lesson. The other thing I have them do is I have them go to the permanent service and they download Pier 6. This is Philadelphia's tidal gauge station, and we get the annual means and they plot it. And the way sea level rise, for those of you who don't know, is calculated. This is a simple linear regression put through the points, and we get a linear estimate. And I just downloaded this on Monday, and it's got the latest data, and it's 3 millimeters per year. And it's really interesting because you can see the sort of temporal variability as well. You can see ENSO events in the sea level rise. You can see the movement. So these up and downs are affected by the movement of the Gulf Stream, ENSO events. So sea level rise is very variable, but there's this very clear trend. So what do I have them do? I have them look at 4 scenarios, 2050, 4 feet of sea level rise. The mid-range IPCC for 2100 is 3 meters, and we look at that one as well. So I'm going to take you to the site that we use, and hopefully I can find it here. Where did it go? Just give me a second, folks. Of course, I'm having technical difficulties, right?
Do you need my help, Frank?
I had it open just a minute ago, and now it's not appearing. All the others are here, of course.
Of course.
Let me just go back to the.
I can also share the link in the follow-up.
I got it. It'll come up in a second.
All right, great.
Let me try it again. There we go. So this is put together by NOAA, and it's a great site. And what we can do is we can go, and it's one of many along that are developed like this. I get them to go to Philadelphia, and this is part of the discussion in class. And they have a practical exercise that they work on and answer questions. So if we look at the Philadelphia area, this is the current situation. The green stuff are low-lying areas that are commonly flooded now during high tide because they're low-lying. And what we can do, I have them look at two things. I have them look at the valley here, the Delaware area, and specifically the airport. So if we go to the 2050 and we elevate sea level 4 feet, you can immediately see what begins to happen to the airport. We can see the Navy Yard and the areas in here. And they get a set of questions that they're required to answer. And then we also take them to the mid-range IPCC scenario by 2100. And you can see the problem that Philadelphia and the immediate Delaware Valley area have. So they're going to have to do something to the airport. They're obviously going to have to do something in South Philadelphia. It's a wonderful site. You can build local scenarios. You can build in marsh migration examples. It has a vulnerability map, which I asked some questions on, and it's got a legend up here. I know this thing keeps blocking it on me. So it's a great website for this sort of stuff. So let me get back to my, share that. So what do I have them do is they answer some questions based on this, and this is what, okay. So the 2050 scenario, what they should get out of this, and they can look at the map in more detail. It means a loss of 2,000 homes, 4,200 people displaced, 63 miles of roads, 23 hazardous waste sites become flooded, and the loss of a total loss of about $686 million for Philadelphia. They can get these data from inside the site itself. The 2100 scenario, 9 feet or 3 meters, about 8,000 homes, about 75,000 people displaced, 227 miles of road, 114 hazardous waste sites, 10 towers, 2 museums, and about $1.8 billion worth of damage. The other example I use in the class is I look at soil formation, human activity, desertification, and food security. The last example I want to take you to really quickly here is we look at population in the Middle East in this particular class, and it's got the fastest growing population in the world, about 6.6 million people per year. Again, lesson 8, population dynamics. This is a sort of a practical exercise, web exercise that they do. We start off at our map, and the Middle East is particularly problematical because all of the population is essentially clustered around water sites. So that gives us our problem. In this case, we use population profiles. And what I will do is take you to the website and show you a really interesting website that you can use. I don't know why this thing keeps disappearing on me. It's all right. Open link. So this is a really good website. So this shows you the population profile for the world. And Lisa will have all of these sites and they're available in the, but what you can do is this kind of shows you the structure of population, male versus female, and in 4-year cohorts shows you how the population is broken down. It allows you to track and project population forward. And you can add it sort of at 5-year increments and change the population profile. And for this course, for example, if we go to Yemen, this is the more problematical population profile. And the things you can do is you can go here and get sort of the exact numbers per cohort. Essentially, 50% of their population is age 15 or less. And they answer questions about delivering healthcare, education, what it means for the workforce. This means that there's lots of young people who are not making it to older ages. So we have examples with that. We do a comparative analysis with Turkey, for example. Turkey has a different structure. It is a more developed country in the Middle East. And this is following more of the sort of Western pattern. Population growth has slowed down. And we can take them to compare that to a Western European example where the population is actually getting smaller. And then there's a couple of interesting ones that we look at. For example, the oil states, the UAE, for example, we have this gigantic bulge. These are the guest workers. Essentially, the UAE has 2 million Emiratis and 7.5 million guest workers. So we talk about the sustainable development, sustainable delivery of healthcare, education, and employment. There are other interesting things on this website that you might find of use as well. This is a particularly interesting part of the website. You can look at annual emissions by carbon. So the standard here is the United States, Russia, and China, and you can kind of track this through history. You can add countries. You can add India, for example, and track them. Also on the website are other types of maps and features, as you can see here, which support many different sorts of types of classes: health, economics, medical, education, and other sorts of things. So that brings us to about the end of that. So that's sort of 3 ways that I do it to try to integrate sustainable topics into things that are not necessarily sustainable, or at least intuitively obvious. So with that, I'll open it up to any of your questions.
That's really great. I will make sure to include links to those resources and the email follow-up so you don't have to dig for them. But those are very interesting, especially that population one is quite fascinating. I don't know if I've ever seen a map with a bulge like that. So that
yeah, there's a lot of, I mean, it has every country in the world just about, and there's lots of interesting stories you can find in those population profiles that talk about. You know, you can see the effects of war in some of the population profiles. You can see, in fact, if you look at Ethiopia and Somalia, you can see the great drought of the 1970s and 1980s. So those are really helpful tools to use in a class. So.
Fantastic. Does anyone have any questions before we end the recording? Going to.
Well, thank you everyone for your attention.